Okay, thank you for introducing my name is Kazuya. I'm from the Osaka University, and today I introduce the exploring the emergent behavior of the particle linear perturbation response analysis for computational agency. So firstly, we explain the motivation. So how to discover the agent, the whole system. So this is the overview of the system. So the most huge, the class is a dynamical system. It's a time evolution. And the second one is the system with goals. For example, the following the ball. The ball is the follow the gravity, and the ball is falling. This is the system with the goal. And the next is the adaptive system. The like a robot is interaction between the environment and then also the another one is a autonomous system. This is more the self-organizing and also interact between environment. So and this area is a very obvious the definition, and but we believe the system is has an agent. So we try to access this system using the very simple model. So what features are essential to the computational agency? So the Barrera says the three components: the self-boundary, self-maintenance, and the self-generation. The self-boundary is make a boundary between the self and the environment, and also this system need to maintain this boundary. Also the generate by themselves. So this is a schematic view. So this side is generate the self-boundary using the chemical reaction or something. Also, after the make a boundary, that this is the agent. After that, the agent need to the interaction between the environment and maintain and survive in the environment. So, is there the theoretical framework with which agency can be expressed? So we focus on the linear. So because the linear has a various self-generating the pattern, the linear is a basically the cellular automata and the 2D system, and basically the linear determine this pattern two parameter, the kernel K and growth function G. The kernel K is a determine which neighboring cells information to obtain, and G is a update loop to determine the next state. So basically the linear system is updated this equation. But the cellular automata linear is a little bit difficult to apply the perturbation. So there is a new related to the linear system. It's named the particle linear. It means linear as a multiple particle system. So basically okay, I will little bit demonstration. Yeah, this is a particle linear demonstration created by the the Google team. So, for example, we can easily to pick up the part of the like this. So we can easily to apply the perturbation like this, and the particle linear is also generates the variety pattern similar to the linear. For example, this is a moving pattern like a glider. And also the rolling pattern is also emerged. So we go back to the notation. So we use this particle linear and investigate the self-generation pattern and the self-maintenance behavior through the perturbation response. So we firstly apply the very simple storage perturbation. Storage perturbation means, for example, that this is a stable pattern. So we press this pattern in one direction, and what happened this pattern. So, and the particle linear is basically the energy total has each particle has an energy. So this y axis is the total energy of the system, and we try to firstly the random position and decrease the energy and get the like this stable pattern, and we apply the stretch perturbation here, and we investigate after the post perturbation. For example, this is a movie of the pre-perturbation. Decreasing the total energy and get the stable pattern, right? Like this. After that, apply the stretch perturbation, the particle linear, switch another stable particle configuration. So this is the example. So we try to search the multiple the parameter. So we change the growth function. The growth function, in this case, the growth function is express the Gauss function. So the parameter, the two parameter, the sigma and mu. So we change this two parameter, and firstly we searching the pre-perturbation pattern. So this is a phase space of the pre-perturbation stable pattern. X axis is a sigma and the y axis is a mu. So we find the variety of the stable pattern. After that, we apply the stable pattern to the stretch perturbation. And this is a example. This three movie is collected this parameter, and in this area is a particle doesn't move, but this parameter is here. Dynamically, they're moving and still keeps moving. And these three movie is these three parameters. There is also almost doesn't move. So we briefly characterize the for the perturbation, the static response and the dynamic response. So, and the dynamic response is basically unstable, but the response can take a wide range of the pattern. So we guess the dynamic response is a strong to the perturbation. So we try to characterize this dynamic response. Okay. Okay, so how to characterize the dynamic response? Okay. Yeah, basically we calculate measure the two feature, the time instability and the diversity of the metastable configuration. Yeah, time instability is this is a energy landscape. You can imagine if the time instability is high, the state is a very arbitrary move, but the time instability is low. The system can converge to the stable state, and the diversity of the metastable configuration means how many this body exists. So we can calculate this, and yeah, this is the result. And left is the diversity of the metastable configuration, and the right is the time instability. And the region shows the dynamic response with high diversity in metastable stable state and time instability. I mean the white space. And say again that we show the dynamical response pattern. Yeah, we call that this is a worm, and our message, the worm is also unstable, but can maintain their structure against the perturbation. So maybe this feature may be important for the self-maintenance. Yeah, summary of the result and the feature implementation. So we need only the one parameter sweep. So we need more parameter sweep, and we can analyze that using the trajectory of the total energy landscape, and also we try to measure the directly the agency because recently many measurement of the agencies exists. Yeah, that's all. Thank you.